Hello everyone, this is Atriya and today we'll be solving the problem winning strategy, which is a cakewalk problem. Let's get started. Here in this problem, we are given an array of integers basically. An array of integers are given to us and these are positive integers, keep in mind. There are two players, P1 and P2. In each turn, a player who's playing in that turn can select one element from this array and add that element's value to their current score. Initially, both the players start with 0 score. Now, what is the catch in this problem? The catch is the person who plays second can take two elements in his or her first try. So, what does this mean? This means that if P1 goes first, P1 will pick an element. Okay, P1 will pick an element from the array and that value will be added to his or her score. Then P2 will go. But P2 can pick two elements since this is player 2's first try. What is this? This is the first try of P2. During the first try of P2, they have the option of picking two elements from the array. Then it becomes a normal game. Then P1 picks one element from the array, then P2 picks one element from the array, P1 picks one element, P2 picks one element, so on and so forth. Whatever element they pick, that value will be added to their score, their current score. The only catch is during the first try of player 2, they have the option to pick two elements. That's all. Now, let's look at the sample cases. In the first sample case, what happens? First, let's say P1 goes. Okay, P1 picks this element at ARR of 0. Assume 0 indexing. Then player 2 goes, but you know that player 2 has the option of picking two elements in their first try. This is the first try. This is the first try of player 2. So player 2 picks ARR 1 and player 2 picks ARR of 2. So final scores are the person who goes first has the score of 1 and the person who goes second has the score of 2. So what is this? Player 1 started and player 1 picked this element. Now player 2 went, but player 2's first turn this is, so they can pick two elements. So they pick these two elements. So their score is 2. Now this means that no matter what happens, if you go second, you have the potential to win the game. That is why it is second here. Now let us look similarly in this. Let's say player 1 goes and player 1 picks ARR of 0. Now player 2 goes, okay. Player 2 goes and let's say that player 2 picks ARR of 1 and ARR of 2. Now player 1 again goes, it's player 1's turn. Now player 1 cannot pick any of the already picked items. So player 1 picks ARR of 3. So what is the total scores? Player 1 picked ARR of 0 and ARR of 3, as you can see here. ARR 0, ARR of 3. So the sum of that is nothing but 2. So player 1 score, let me write it here. Player 1 score is 2. Now what did player 2 pick? Player 2 picked element at indices 1 and 2. Now their sum is also 2. So no matter who goes first, this game ends in a draw. So how to solve this problem? Now we must note that the first thing that we must note that we must sort the array in the descending order. Why? We want to maximize our score so that we win against our opponent. The trivial way to do this is to pick the largest elements first. If you're going first, obviously you want to pick the largest element first. Let's take the example of this array here. Let me write 20, 10, 9, 7, let's say 5 and 1. Let me write 0 indexing here. We'll understand the approach with an example. Now I've just taken, assume that this is the array after sorting in descending order. Now what will player 1 do? Player 1 obviously wants to maximize his score, so he will take the element at the 0th index, that is the maximum element, this element. Player 2 now unfortunately cannot pick the maximum element, so they will do the next best thing. They'll pick these two things. Why they can pick two things? Because this is player 2's first turn and hence they have the option of picking two elements. Never forget this. During the first turn of player 2, they can pick two elements. Then it is player's 1 turn again. Now player 1 cannot pick 0, 1, 2 elements. They can pick the next maximum so far. That is the ARR 3. Now what will player 2 pick? Now player 2 cannot pick 0, 1, 2, 3. So player 2 will pick ARR 4. Now what happens? Now is player 1 turn. Now player 1 will pick ARR of 5. So do you understand that a pattern is going on here? After we sort the array in the descending order, what are the elements that player 1 will pick? Player 1 score, the person who goes first, let's say player 1, their score will be nothing but the sum of the elements at indices 0, look at this, 0, then 3, then 5, 0, 3, 5, 7, so on and so forth. Now the sum of the player 2 will be nothing but element at indices 1, 2 as we picked here, then 4, then 6 and so on. So it suffices in this problem statement to run a loop and find these sums and then check which is greater. If P1 is greater than P2, we tell them go first. If P2 is greater than P1, you say go second. If they are equal, you say draw. Hope this approach was clear. that we have just discussed. First, we look at the C++ code. In the C++ code, after inputting the array, we sort it. Now here the greater part is included as a comparator in order to sort the array in the descending order. Then we have first and second variables to keep track of what will be the score if you go first, what will be the score if you go second. Now remember, if you go first, the score will be the sum of the values at indices 0, 3, 5, 7, so on and so forth. So if I equal to 0, index equal to 0, have first equal to first plus ARR of 5. Otherwise, it is second player's turn. And during the first try of the second player, they can pick two elements. That is why if I is 1 or I is 2, second equal to second plus ARR of 5. Otherwise, if I mod 2 equal to 1, which means that it will be indices 3, 5, 7, 9, so on and so forth, have first equal to first plus ARR of I. Otherwise, for indices like 4, 6, 8, so on and so forth, you have second equal to second plus ARR of I. Finally, you compare. If first equal to second, you print draw. If first is greater than second, you print first. Otherwise, we print second. So hope this approach was clear. So the time complexity for this solution is just O of n per test case, because we are just traversing the array and we are comparing at the end. We have AC here, as you can see. Let's move on to the Python code. In the Python code, after inputting the array, we are sorting the array and then reversing the array. Basically, we are just sorting the array in ascending order and reversing it so that it's descending order. We can combine this in one step. Now answer 1 stores the answer if you go first, and answer 2 stores the answer if you go second. For every index, you do this. Now always remember, for player 1, it will be the sum of values at indices 0, 3, 5, 7, 9, 11. For player 2, it will be the sum of values at indices 1, 2, 4, 6, 8, so on and so forth. 1 and 2 are during that player 2's first turn. Now if index is 0, you have answer 1 is answer 1 plus ARR of index. Otherwise, if index is 1 or index is 2, you have answer 2 equal to answer 2 plus ARR of index. Otherwise, if the index is of the form 3, 5, 7, 9, you have to add it to player 1 score. Otherwise, if it's a form 2, 4, 6, 8, 4, 6, 8, because 2 is already handled, if 4, 6, 8, etc., they are even, they have to be added to player 2 score. At the end, we just compare. If the player 1 score is greater than player 2 score, say go first. Otherwise, if the values are equal, you say draw. Otherwise, you say, go second. Hope this part is clear. As you saw, we got an AC for this Python solution also. Hey guys, that was it. Thank you so much for watching this video, and if you haven't yet done this, this is a gentle reminder to hit that subscribe button. If you're interested in competitive programming and data structures, this channel is a one-stop solution for you. See you in the next video. Bye.